Hello there, today we'll be talking through the code for the Abacws data visualization tool that I've built for my dissertation. So first of all, let's have a look at the API. So as you can see, both the API and Visualizer are services hosted using Docker. We use this Docker compose file to host them both together, and they network to each other through that. Now the API tool is written using TypeScript and Node.js. So this file here starts it. So it's obviously we import the port from a constants file, and then we tell the app to listen on that port. Now the app imports the API, so that it's made up of a bunch of sub routers essentially. So we have the API, which then registers. Health check one is just an endpoint that returns OK if the database is reachable. But the query and devices endpoint, these aren't endpoints, these are routers, which we import from the routers folder. So we'll take the query one as an example. So this is just a utility function, you can ignore that. But these functions, all of these ones correspond to endpoints on the API. So we've got one this is for the advanced query stuff, so you can either query the info, the data, or the history. And these all they run a database query, and they build the filters from the provided parameters. And then they get registered in the router like this. The utility function here just builds the filter and projection objects for the MongoDB queries and then returns them. As you can see, it's in use. If I highlight that out, it's in use in all of these functions just to build the filters from the parameters that we pass to it. Picks a from and to, and then ensures that the timestamp is in that range. And we've got this query middleware. The great thing about Express is you can register any number of these handlers after each other, and then they can pass data forward through the chain. So if you look at the query middleware, this one performs the common functionality between all of the query endpoints. So this reduces the amount of code. Otherwise, we'd have to write this, once for each one of these. But instead, we run it through this, and then this calls the next endpoint handler and stores the result of the filters in the. This is just an object you can assign anything to on the response before it gets passed along. And one thing I've implemented on all of this to simplify the import statement. This is called import barreling. You can barrel them all together in one index file, and that simplifies how they get imported. So if you look at this API one, you see we're importing, for the middleware, we import these error handlers all in one import statement instead of 3 separate import statements, and the same thing for all the routers. And also it allows you to rename them like this, because it's called a router in each file, and then you can rename it when you re-export them up. I've used that throughout the program because it makes things easier. So we have so that's how the routers work. There are more. The documentation router is kind of interesting because it works a bit differently. It imports this OpenAPI YAML file, which defines the API as I can show you what the documentation looks like. If you've read the report, you'll have seen it. But basically, it generates into this, which provides helpful documentation for each one, such as what parameters it takes, what sort of data it returns as well. And it documents authorization as well, which is another thing I'll talk about in a second. So each of these paths, you can define what it does, you can define what HTTP methods you can use to query it, and then the responses it could possibly return. So in this case, this is getting a list of all the devices registered in the system, and either it returns the list of devices with a code of 200, or it returns a database failure response with a code of 503, which is it's just a database unreachable. I think it's an internal server error code. So that one's that, and this just reads the file in, passes it, and then this is just an endpoint to return that if you wanted to use it. Right, so the authorization, this is another piece of middleware that we assign for any, that's the wrong file, for any endpoints that require authentication to work. So you can see in this file, if I scroll right to the bottom, I've got it for anything that adds data or deletes data. So this endpoint here is where you upload data if you were adding it to a device normally, and then this one deletes it. So it checks the API key first. At the moment there's just a single API key assigned from an environment variable. So the constants file here, you can see it checks the process.env, which is the environment variables present, and then if that's not found, it will assign a default value, such as in this case the default port is 5000. The default MongoDB URI is localhost 27017. And for this one we don't need a default because that will just evaluate the false if that's undefined. They all use this error logging, so this helps. So this will, if there's ever an error in the system, it'll get console logged to the database as well, and then this one just returns a response to the request that caused the error. So if I sent a request that returned an error, I'd receive something back, as otherwise I wouldn't if I hadn't registered that. So the devices are all stored in this file. This offset here it acts as a 0 point on the model. So each of these positions is offset by that, so that they appear relative to the center of the 3D model of the building. Now the database here, this one's fairly simple. It just imports the MongoDB URI from the environment variables and then tries to connect it. If it fails to connect, it'll log out the error. And then this function here handles the importing of all the devices from this file here. The generation script as well. So this just generates random data for whatever devices names we pass through, and it stores them in the database by itself. So you can see it inserts them here. Yeah, more or less. The rest of these are just config files. I've got a README as well. Shows you a preview of what the website, what the documentation looks like, and what environment variables are important, and how to override the device in the custom device list. Inside the devices router file, we have ones for querying the entire list of devices. So that's what this one handles. And all of these other functions pertain to specific devices. So you see they all take a device. If we go down to the bottom here, they'll take a device name, you see, when we register them, and we use this middleware here to fetch the data for that device. So we don't. So this is, once again, this is duplicate functionality that we've extracted and put in as device middleware. And so you see, we only have to register this in one place. In fact, we just register it for device name before any other device name things, and it gets the device for all of these. So onto the visualizer. The visualizer is made using React and TypeScript. So it's the same language across the board. So we have this core component up here. So this is the main component, and then all the children of this are other components that I've built to make the application look how it does. So we've got the model view. So that is the one that displays the 3D model and allows you to navigate it. As you can see, we load and mount the graphics using the graphics. The graphics is just, it's probably better if I show you what it is. It's a big class which defines all the stuff for the 3D rendering. When you call use graphics mount here, it calls the init method on the graphics object, which is, it's a singleton object, so there's only ever one of them because we don't need to display more than one, and it's easier to just make it a singleton to access it. We add the canvas, which is what it uses to display it. Now that's what this DOM element is on the renderer, to the window, or not to the window, to this element here. So it binds it through that, and then we have this loading spinner which uses this use graphics loaded, which this value changes when the graphics object loads. It dispatches a DOM event, if I can find it. Yeah, window.dispatch event, a load event. So here's where we set it up. We import the model as a bunch of layers. These are all stored in here. So as you can see, there's decoration, exterior walls, floors, glass, that sort of thing. Those all get loaded separately and layered on top of each other to form the main model. This renders a new frame. So this gets called 60 times. So then we have things like the dispose method, which gets rid of, it unbinds everything from the window. All the event handlers that are no longer required when the graphics object gets destroyed. This doesn't get used. This only gets used when you're hot reloading the program, which shouldn't happen during normal cases, but it was very useful during development because it made my life a lot easier. I didn't have to refresh the page very much. So we have down here, we've got some setters. So we have things like set floor. So this cuts the model off at each floor depending on the floor number you give it. And then the devices, this just adds each device to the scene. So it clears the old ones, adds each of the new ones in turn. This gets run after we request all the devices from the API, and it adds them all at their respective positions, which it gets. So yeah, it gets all that from the API. So effectively, it gets it directly from this data file here, the devices.json, with this offset applied already. Let's close this so it doesn't get confusing. We had some lighting to make it look a bit nicer. This is a resize handler, so whenever the screen gets resized, it correctly scales the camera aspect ratio. Otherwise, it wouldn't move whenever you resize the window, which would be really annoying. This method, this is one of the more important ones. So every time you move the pointer on the canvas it's rendering to, this checks if your cursor is over one of the devices in the scene. So we do this using ray casting. So we cast out a ray to intersect with the children of the device scene, which are all devices. And then if it detects an object, we take the first of that object and we execute this device hover enter, which just changes its appearance and places it on underscore hovered device so that we can access it later when we click on it. So yeah, we'll talk about that method. So that's down here. Oh, let's look at the pointed down one as well. So pointed down, this occurs whenever you click or tap on the window if you're on a touch screen, and then it changes. So if you're hovering over a device when this happens and you left clicked, that's what this button check is, it triggers this other method which handles the actual change. So we have the device hover enter and device hover exit here. So this makes the device change color and it makes it get a little bit bigger, the geometry. When you hover over it, this resets the changes when you stop hovering over a thing. And the pointer down here, so it makes the hovered device the selected device if you've clicked on a device, essentially. And then changes its appearance again so that you know that you've got it selected. And then we dispatch this event, which so the graphics library, the graphics code and the React application are bound together using DOM events. So we fire this event to notify the rest of the program that we've selected one of these devices, which we can then access using these hooks for React. So the way these work, so this one here actually allows you to set the state, because you see it returns a setter, which changes this the selected value on the graphics by dispatching a DOM event in return. So the graphics library, I keep calling it the graphics library, the graphics module, which is what this is, can receive events to allow you to set the floor. I can't receive events for device selection because I didn't think it was necessary, but you could add one using the same sort of method. So yeah, this just dispatches a device select event. So when a device select event is received, rather, we update this hook with whatever state is, and that, because it's React hooks, this will automatically change by itself, and we can intersect that further up in other components. And it's useful because it means we don't have to write this out whenever we want to do it. We just have to call this hook. Otherwise, we'd have to write all of this, which would be quite annoying. And the use selected floors are very similar, apart from this setter function that it returns dispatches a floor select event for the floor, and that's what it returns. You see, it returns both. So you can, when you use this hook, you can dispatch an event in return, which I'll show you that in a second, because that'll be a good example of how it actually works. So I think that's so this use effect hook, if that callback value changes, this gets rerun and it removes the old event listener and adds the new one. We make quite a lot of use with hooks because they simplify a lot of the React stuff. So that's everything to do with the model view. Now we move on to the data view, which is where that's that portion on the right hand side of the screen that allows you to read the data off the devices. And as you can see, so we're using, I'll talk about the styles now. So we're using Sass, which is effectively just better CSS because you can have proper variables and it'll inline them for you. So it will work with all the browsers. So this is all the button styles. So as you can see, we can generate all the button styles from these variables using a for loop and these things called mix-ins, which allow you, these are sort of, what's the best way of saying this? These are templates that you can apply to styles. So you see here we create button.name and .button.name as a style, and then we include this style. So it means instead of writing this out, 20 times or how many color sets you've got, you can write this instead and it'll do all of it. So what can we talk about next? Let's have a look at the hook, shall we? So as you can see here, we use barreling as well because barreling simplifies the import statements so much. I thought it was really worth using. So we have our API hooks. So here, this use API one, it'll send out a request. Whenever the URL changes, it'll refresh that, but this only runs once. The API subscription one will regularly refresh the value and return that. These are used, so these are the raw well, these aren't actually quite, because we use this API fetch function, which is a wrapper. So this wraps around the normal fetch API in the browser, and it just automatically, it says, hey, I want this in JSON, because we're doing a JSON-based REST API, so we always want to receive JSON. We don't care about anything else. So this just requests JSON, and then we return that, and we add the status and the success. Now, use devices gets the device information. So these just wrap around these use API and use API subscription hooks, but they query specific endpoints depending on the parameters they're passed. So this one just requests all the devices from the API. This is for the details of the info from a particular device and so on. You get the idea. These API subscription and these two refresh automatically. These don't change very often, so they don't need to refresh, but these can change very quickly, these responses. So it's worth using a subscription here. I mean, this refreshes every 10 seconds, so it's not a massive overhead. So now the data view. So we got more styles in here. We make use of media queries. So this will be if the screen is less than 500 pixels in size, the data container will take up the whole screen, that sort of thing. These are very useful. So now we have the data view. So you can see we use the selected device hook here. So this just automatically refreshes when we select a device. This part of the interface automatically refreshes when we select a device in the model view. And then we request the device info data and history, which we then display using more subcomponents. So we've got the floor selector, which handles, see this calls set floor, because we use the use selected floor hook as well. So this returns floor and set floor. Now the floor is the actual value of the floor, which we passed out of the floor selector, and then set floor is a function that we can call that, and it will update the model view accordingly. Now we make use of tabs in here, because you see there's actually two different things we can do here. We have the device details and the graph, and then a query panel, which allows the user to use the advanced query functionality. So we tab them off so that they're not both visible at once, because you don't need, this is more of a secondary use case. You don't need this often. So we split them apart. And this tab is the one that's active by default. So we use this tab index state. So the state we can set this, and then it'll refresh this view. So you see we have set tab index. So when we click one of these buttons, it changes which tab is selected and changes this bit down here. This graph options, this is just what's currently being plotted on the graph, and then it works out if it's being hidden, because we have the little X button in the top corner that you can click to hide this away, and that's what handles that. I believe that's all for this one. So let's have a look at device details. So this is another React component. This builds up. So let's go from the top. So the device details. This builds a table. This bit here. It builds a table displaying all the data to the user from the device they currently have selected. We have an export icon here if they have a device selected, and then you can click. So there's this on view history, because you see this has the options field which allows them to view history. So this registers this callback, which then goes back up the chain. So when you click on the view history button, it goes from this function, it goes back up to here, and then this actually goes even further up, because this takes a device name and a field, but this one here only takes a field as an argument, I believe. No, it takes nothing. So we wrap the functions up, and then it goes back up the chain back to the data view, where it then changes the state of the graph container. This is a good example of what makes the barrel imports so good, because as you can see, this takes up 5 lines, when previously each one of these would be an individual import, with the exception that these two would be the same. So there'd be 4 imports here instead of 1 line of imports. So the barrel imports, they're really good. They're really useful. Right, let's have a look at the floor selector next, I think. So this one's quite simple. This just has a bunch of buttons. And then the button that's active gets this active class on it, so it looks a bit different. Right, so React components, they take props, which are things you can pass down to them. And then they also have state, which is state that's internal to itself, that can't be set by something further up the chain. And props are read-only. So this floor button is provided these props here on select, which is the function that we call when that option gets clicked. Current, which is the current value, and then the number of each, because there's 7 floors, so we generate 7 buttons like this and put them in the floor selector. So then we have the graph container. This one's a little bit more complicated. Not from this level it isn't, but further down it does get so. So we take these graph options, which we then pass down to the graph when it's being used, and we have these formatters, which make things look a bit nicer. So we've got this util folder. So as you can see, we have the Unix time formatter, which takes the Unix time as a string or a number, turns it into a date, and then converts that to a time string that's easy to read. Obviously, people don't want to be reading Unix time. And then what else here? So we go down to this. Obviously, we have the styles for the graph container. So then the graph here, here's the actual thing. This is built using a library called Recharts. It's a React way of building graphs, essentially, because it provides all these components that you can then add together to customize what your graph looks like. So we have line chart. You can get the x-axis, y-axis. You can define what the labels are, how they're displayed, what's the style. So you can add capitalization. You can anchor it to the middle. You can change the colors. The lines as well, you can change the colors, change the active dot size, which is when you're hovering over it. It has a little dot where you're hovering. The tooltip, which we've got this other class we've made, or other functional component called time tooltip, which uses the formatters we showed in the util file. So when you hover over the graph, it puts a little line over it and tells you what the timestamp and the value of the field is where you're hovering over it. Essentially, that's what it does. So that's the graph container done. So now we have the query panel, which is just a big form, essentially. Now React is a bit weird using forms. I have to say I don't like its form handling very much. So this is just our onSubmit function, which, as you can see, gets all the values from. So we get all the values from the form, and then this builds a URL, which we then query for the result. And then you can download files by creating this dummy anchor element and fake clicking it. This is a bit janky. I don't like it very much, but that's the JavaScript way. So yeah, we get all these values from the query form. If I collapse this, we'll be able to look a bit better at the rest of it. So each of this is just a normal HTML form, essentially. There's two ways of doing forms in React. You can either do a controlled one or uncontrolled. This is uncontrolled, which means the HTML maintains the form. We don't deal with it. The other way of doing it is having it so when you change one of these fields, it stores the value using React and then changes the value back on these. As you can see, we have this query panel form. So this is what gets returned in this. So the event target, we say it's query panel form because that allows us to query it like this. So we have a few other components that we use throughout the program. These are used in all. Well, these are placed here because they don't belong in a particular view. They just can be used anywhere. So we have this. This is the little hamburger toggle on the side of the screen. It's very simple. You just provide an onClick function for it, and that gets called when it gets clicked. And then what's this one? And then you can define whether you want it to display the little cross when it should be closing, and I quite like that. So, but it's customizable. And it's just the hamburger icon is just built out of 3 HTML elements because it means you can animate it yourself. So as you can see, we've got all the animations and stuff defined in the CSS here. And here you go. When it's closed, we rotate each of them, and then we hide the third one so it doesn't interfere. And these two form a little cross instead of the 3 lines that are normally on one of these menus. So it means this one hides, and these two here form a cross. The icons are okay. Well, we have a folder for icons here. These are Clarity Design icons. They're open source icons with, if you attribute to them, you can use them any way you want, and they're all very high quality. So I use these in a lot of projects. And so here you see we define the icon thing. So we got a width and a height set. The colors, which we get from the variables, it just applies the image as a mask, so you can change its color to whatever you want. So we have this icon. Each of the icons take 2 props. You can give them a class name or an onClick. And then the export icon itself is just a wrap around that icon that changes the class name to export. And then you can also provide a class name to this. And then we wrap both of those, you see, in this icons. Well, we don't wrap both of them, we just wrap export because icon is not important. So we wrap the icons in icons export, which means I'll show you where that's used. It's in 9.3 views, data view, device details. So you see where we do icons.export. That's what that does. That displays this export functional component. So that's the icons. Then we have a spinner, which is it's another thing a bit like the hamburger menu, where we just make this out of HTML and animate the dots using animation delays. I'll probably talk about the Nginx template. So when we make this into a Docker container, we use Nginx to perform the proxy of the API for us, because it means we don't have to deal with any cross-origin response headers. So yeah, and then this template config file, it just replaces these values here with environment variables. So the web port gets changed to whatever it is. It defaults to 80, and the API host by default is API on port 5000. As you can see here, that's what those are. And the Docker Compose nicely builds networks for this, so that API resolves to whatever the IP address of the API container is. so they all automatically get routed through. And we have a README for this one as well that tells you how you can configure it and whatnot, and where it's hosted. We can talk about the automated workflows as well. We've got two automated workflows that package the Docker images. As you can see, they're both pretty similar. The main difference is this uses Git LFS, which stores the large asset files, because you're not storing the asset files directly in Git is a bit, it's bad practice, because it makes the Git repository really big when it doesn't need to be. So LFS stores these files in a separate repository, which makes it take up less space. So I think that really is the only difference between those two. But this essentially just logs into the GitHub container repository, which is where I'm storing these as me, using these environment variables. So obviously no actual details here. This step builds the tags and labels for the Docker images. So the tags are, in this case, it'd be like API latest or API and then the version, because you see this runs on when you create a tag on the Git branch, which is how I do versioning. And this just builds and pushes the Docker image up to where it's supposed to be. You can see here we have the packages, Abacws data viz. This is the Docker stuff. So this is where the Docker images are hosted. So as you can see, we have one that tracks the main branch. Then we have a latest, which is the sort of production ready one. And then each version gets its own tag as well. You see there's a container, there's a tag for the API and there's a tag for the visualizer, so you can deploy them both separately, essentially. And that's what, in this Docker Compose file, you see we have API latest for the API, visualizer latest for the visualizer. And then we use Traefik to route the traffic properly.